Right, so question number 7 is again an organic question. So you have given uh, to reactant and the product, then you have given the reagents and the list of the chemicals that you are going to use. And we will first go through the reagents a bit. So you have given palladium, barium sulfate, quinoline. So this one will convert a triple bond to a double bond. Okay, you should know that. And alcoholic KOH will remove this HBr. So automatically you can imagine there is 2 Br that is given. So when you add alcoholic KOH, there will be a triple bond that can be formed. And even this triple bond be converted to a double bond using palladium, barium sulfate, quinoline. And sodium borohydride will be used for the reduction. And HgSO4, H2SO4. So you know HgSO4 and H2SO4 mainly react with triple bond to give you the addition of water via carbonyl carbon. Okay, so these are the reagents that they have given. So now we will go through the type of conversion that they have asked. Okay, sorry. Right, so I will share the screen for myself. So here we have this weird compound. And we have to convert this to this double bond, CH and the benzene group, and CH3. So if you think a little bit, okay, so you can use the same idea like going from the front as well as going from the back and then try to combine as the same way. So I could imagine, since they have given palladium, barium sulfate in the quinoline medium, this might come from this triple bonded carbon to this hydrogen, CH3. This is one idea that I think, right? Since this is triple bond to double bond, and since we have given the reagent palladium, barium sulfate, quinoline medium. Okay. So this quickly gives you the idea. This can be a part that is attacked here to an acidic hydrogen if you have an alkali. So we can check whether they have given an alkali here. Okay. So in principle, they have given sodium to us. So you can understand how we can approach this. So if you have like this part, like sodium thing, right? Then you can attack to this triple bonded carbon and you can add this part. So to add this part, there should be a compound okay with a X group that can attack this position, and here it should be the group that is going to attack. Okay, so this is the way that I can come up to this. I cannot move forward. Okay, and from here I could imagine, since they have given alcoholic KOH, I could imagine this should go like this first. There should be a triple bond CH here. So we have alcoholic KOH, which is promising for me because I have seen here this And here, if I add sodium, I can obtain this part. Right? So the only necessary thing to make is this. So how can I take this from this? Then it gives another reaction that is already given here, is the HgSO4 H2SO4, which will eventually make this a carbonyl compound. And since in the medium they have given the reducing agent sodium borohydrate, you can make that as an alcohol. And they also have given PBr3, then you can make this X and then you can attack. I think this is the way I guess. So you can here add HgSO4 H2SO4, which will make this as a carbonyl compound CO CH3. Okay, this is not CO here and CH2 here, right? In the hydration, remember, you know, in the addition of water, hydrogen should be added to the hydrogen with highest number of carbon. Okay? Carbon with highest number of hydrogen, like the Markovnikov product. So you will have this one, and you can add sodium borohydride. So this part will be OH and CH3 and the benzyl group. So I have to convert this to this. So you need to just replace this OH by X. So you can add PBr3, which is given. So this will be Br37. Then you can just add these two. Then you will have this triple bonded product. Then you can add palladium, barium sulfate, quinoline medium. Okay, so we will come back to this again. So we can start from the front as well as from the back, as I am telling you every time. But here it is easy because you have given the reagent. So if you know the reactions of reagent, you can anyway predict. The idea is, since you have given alcoholic KOH, I could think about elimination product. And here also, since I have, since there is a double bond here, I could imagine this double bond might have come from the triple bond. So that is this. So here you can automatically think about taking this compound from this one by reacting with sodium because they have given the alkali. And when you want to attack this, the triple bonded carbon, you need to have like a X compound, the alkyl halide. So this alkyl halide can be obtained directly from this hydration and then nucleophilic substitution. Okay, so this is the way it is going. Right? So that is the first one that they have asked. Okay, so all those reagents have been used, and this is the simplest way to obtain this product. Okay, there can be other ways also, right? Yeah. Right, so the next question, part B, says, show how you would synthesize a compound B using compound A as the only starting organic material. So this is very common. We see these only starting organic material all the time. So let's see what we have to synthesize here. So we have the alcohol CH3 CH2OH, and we have to synthesize CH3CH. Okay, CH3. So there are 2 Br compounds like this. Okay. This is A and this is B. So the only, I will stop sharing. So the only available organic compound is this. The first point that you should be able to see here is I see this part here as well as here. Okay. And since there are two Br groups here, I could imagine this should come from like this, a double bond. Okay. You know what should be added here, like Br2, CCl4, the reagent for an example, right? And then I see this one here. Here and here. And how can this form, basically? So it can be a dehydration product, right? Alcohol to alkene. So this could be from like an OH, hydrogen, 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 CH3. Okay. So I can add like H2SO4. Look. Okay. So this could be the dehydration product, which has alcoholic OH and H, and this will be removed when you add conc H2SO4 or either Al2O3, and then you can heat. Okay. Now, how can I come from here to here? Now, still I see, when you see like this, still I see something that is very closely related, because this part is similar to this part. Okay. If you see very closely, this part is similar to this part, because there are two CH3 hydrogen, the only difference is OH, which should give you the idea this can be a carbonyl compound that is attacked by this. That is one idea. Like this one could be CH3CHO that can be attacked by CH3 CH2, let's say MgBr, because CH3 CH2 is here, and this one can attack like this, and this one can be broken like this, and it will give CH3 COH. This carbon can be attached to CH2 CH3. So it is very clear now. It should be clear now how to obtain this one from this. You just need to add PCC, and if you want to get this one, you just have to go with first PBr3 to convert this to CH3CH2Br, and then you can add magnesium diether. So this will be CH3CH2MgBr. Then you can add these two. Then you will come at here and here and here. Okay. This is the way you come from back, and then you can come from the front. Normally, I prefer the method that is going from the back and from the front, or even you can go from the front as well. But the idea is, in organic question, always try to at least write down some expected intermediate from your mind. Try to do that. If you are very weak, try to do how. Now this is form. If you are thinking how to get this one from directly from this one, you cannot have a direct idea. Just try to get try to see from which compound this can be formed. It should give you the idea. So there is a reaction that I know Br2CCl4 reacts. So I can take this from here. And here, how can I form this one? This can be from just the dehydration of the alcohol, this. And how can I this from this alcohol? It can be the aldehyde or the ketone that is attacked by the Grignard. This. Then you can counter in that way. Okay. Always try to come from the back as well as from the front and try to identify some intermediate products. That is the easiest way to do the organic conversions. Okay, and when you practice this, it will become very easy. Okay, so this is done, and we have some information. So let's say, draw the structures of the compounds C and D in the reaction sequence given below. So it is, okay, so we have added conc H2SO4, and then we have added water. So the idea is, okay, so when you add conc H2SO, normally when you have this reaction like CH3, CH, double bond, and CH2, and when you add dilute H2SO4, okay, this is normally what happens. When you have dilute H2SO4, then you will have the hydration product CH3, and there will be OH here, and there will be CH3 here. This is the normal product. But this is a little bit different, right? Because first you have to, okay, I will stop sharing and I will use the board. It is easy. Okay, so you have this one, CH3, CH double bond, CH2. Okay, so when you add conc H2SO4, what is actually happening here is, when you think about the structure, sulfur, OH, OH. So this is the structure, H2SO4. So when you add this, there will be H plus coming from this, and here this one will be combined here. Okay, basically not here, sorry, here. So when you add conc H2SO4, the product will be CH3, CH, this part. Okay, so this is O, SO3H, and here there will be the CH3. There will be a positive charge initially, then it will be done. Okay, so this is H2SO4. The first step of the reaction is, since this is an electrophile, this H plus will be added here to the CH2, which makes this as CH3. And in the second process, I hope you see my screen. Yeah. And in the second process, OSO3H is here. Sorry. And when you add water, what is happening here? This OSO3H is again replaced. Okay, so this is the final product. So the example that I have given you here, I will share the screen again. So this is dil H2SO4. You see, this is dil H2SO4. We are obtaining the same product. But here in this one, we are going with two steps. First, we add conc H2SO for the reaction. And second, we add water, which means dilute in H2SO4, which is, again, it's diluted H2SO4 directly. Okay. So it is observed that the same product D can be obtained directly by the reaction of CH3, CH2 with dilute H2SO4. So that is what I am talking here. This is the same reaction. That is why I am talking here. Explain this observation by taking into account the fact that H2O can act as a nucleophile. So when you have diluted H2SO4, you need to understand what is happening here. Okay. There is nothing much here. You just need to remember about your mechanism part. That's it. Okay. So I will stop sharing. The main idea that is happening here, when you have H2SO4 and when you have H2O, which means the diluted acid, So what will happen here is there will be HSO4 minus. One H is given to this, and it will form the H3O plus ion, which is the hydronium. So when you have this compound CH3, CH double bond, CH2, and there will be this hydronium compound, and this will attack like this, and this bond will be breaking. Okay. Now here, remember, this is the nucleophile. Don't forget. This nucleophile will take H2O, the lone pair will attack here. This bond will be broken like this. That is how HSO4 minus and H3O plus is formed. The electron lone pair here, H2O, will get this terminal hydrogen. And then this will attack this, and this will form the first initial compound, CH3, CH plus, CH3, and there will be water, H2O. Okay. And this water lone pair again will attack this carbonyl carbon because there is a positive charge here. Okay. So there is a positive charge here. And this will form like CH3, and CH will be here, and there will be oxygen attached to hydrogen, and there will be CH3 already. But there is a positive charge here. Okay. Now this bond will break down like this, and finally we will have the product that is expected. Okay. And this H plus that is removing is primarily taken by HSO4 minus. This one will attack here. So there will be H2SO4 at the end. So you can understand H2SO4 act as a catalyst. That is the important thing to identify. Okay. So what is happening here? In diluted H2SO4, this is the normal reaction that is happening. This mechanism you should know principally. Okay. In concaste SO4, first is there is no water, so there is no reactant. There is only H2SO4. So first OSO3 minus is reacting with this one, and then water is going to attack. Okay. So these steps you should understand, and you should know actually, because this is essential in predicting the mechanism as well as understanding what is actually happening. Okay, so this summarizes the situation. Right.